All right, so we're going to begin lesson 5, unit 5, and this whole unit is going to be about quadrilaterals. And in the quadrilateral families, we're also going to be talking about parallelograms. So, but our main focus today in lesson 1 is quadrilaterals. Okay, so let's just jump right on into it. So what is a quadrilateral? A quadrilateral is a polygon, and a polygon is simply a figure with many sides. Poly means many. So we have a quadrilateral is a polygon that has 4 sides. Every quadrilateral, every 4-sided figure has an interior angle sum of 360 degrees. And there are different types of quadrilaterals. And that's what our focus is going to be on in this entire unit. So we're going to jump into the fire and just start with an example. So here we have a 4-sided figure, and we know the angle measure of J, we know the angle measure of S, but we don't know the angle measure for E, nor do we know the angle measure for K. If we know X, if we could figure out what X is, then all we would have to do is substitute X here, simplify that expression, and then that would give us the measure of angle E. And same thing is true for the measure of angle K. All right, so let's talk about how can we go about finding the measure of angle X. Well, we have to remember that the 4 angles add up to be 360. So I'm going to start with angle E, and I'm going to create a little equation. So 5x plus 3, that's plus the 88, I'm just going to go around the figure, plus 10x plus 7, and then finally we have plus 127, and all of that's going to equal 360. Okay, so all I've done is I'm adding the 4 angle measures, and I'm going to set them equal to 360. So now it's just a matter of cleaning this left side of the equation up and solving for X. So let's think about what we have. Okay, so combining like terms, we have a 5x and a 10x. So 5x and 10x will be 15x. And then let's add all the constants. So let's add 3 and 88. That's going to be 91. Add 7 to 91, and we get 98. And add 98 to 127, and I'm pretty sure we get 225. So I have 15x equals 225, and I'm now going to set that equal to the 360. So I have 15x plus 225 equals 360. So now subtract, just solve this equation for x, and that would be subtracting 225 from both sides, and that gives me 15x equals 135, and I will divide by 15, and 135 divided by 15 gives us x equals 9. So there's our value for x. X is 9. So now that we know x, we can actually find the measure of angle E by simply taking the expression for the measure of angle E, which is 5x plus 3, and substituting what we found x to be, which is 9, in for x, and clean that up. So 5 times 9 is 45, and then 45 plus 3 is 48. So the measure of angle E is 48. And don't forget, that's an angle measure, so we need degrees. And then to find the measure of angle K, I'm going to come over here. We can do the same thing. So I have 10x plus 7. I will substitute 9 in for x. And then this is going to give me 90 plus 7, which is 97. So the measure of angle K is 97, and it's an angle measure, so we need to add the degrees. So how could I check to make sure that my values are correct? I could add the 4 angles together, and the angle measures are, let me put those up here. We have 127, measure of angle E is 48, that's 88, and this one is going to be 97. So if I add 48 plus 88 plus 97 plus 127, I'm going to bring it up here, then all of those should add up to be 360. And so 16 plus 14 is 30. So 3, 4, 5 plus 4 is 9. 9 and 8 is 17. 17 and 9 is 26. And that gives us our 360 degrees. So it does add up to be 360 degrees. So here are the values that we were supposed to find. Okay? So all quadrilaterals, all 4-sided figures add up to be 360. And so that's really important to remember. All right, so we're going to get a little practice here. What about, what do I want us to find in this figure? We have a 4-sided figure. I want us to find the measure of angle F. And the measure of angle F is 10x. So for us to be able to determine the value of angle F, we have to first figure out what x is. So we've got several angle measures. We've got expressions or actual values for each angle. All I have to do is add these 4 angle expressions together and set it equal to 360. So I'll start with 8x plus 11. I'll add 82. I'll add 105. And then I will add 10x and set that equal to 360. So combining like terms, I have 8x and a 10x, which gives me 18x. When I add 11 plus 82 plus 105, I'm going to end up with 198, and I set that equal to 360. So now I will subtract 198 from both sides, and that leaves me with 18x equals, when I subtract 198 from 360, I'm left with 162, and then I will divide both sides by 18, and x equals, well, x equals on this one 9 as well. So we have our value for x. Now we've got to figure out, we've got what we need to be able to find the measure of angle F. So all we have to do is take 10, multiply it by 9, and that angle is 90. It is a angle measure, so you have to put your degree symbol. So the measure of angle F is equal 90 degrees. So this angle right here is a right angle. All right, then going on to example 2, pardon me, going to example 2, we're going to, well, it's not indicated which angle to find. So let's just find angle M. So I want us to find the measure of angle M. So the four angles need to add to give us 360. So I'm going to have 10x minus 5 plus 8x plus 13 plus 95 and plus 95. And I should not have used this pen, this particular pen. We set that equal to 360 because the pen is a little thick. So cleaning this up, we have a 10x and we have an 8x. So that's going to give us, what, 18x? And then I have, okay, I've got negative 5 plus 13, that's 8. 95 and 95, that is 190. No, it's not. It's, yeah, 190. So that's going to be 198. I think, well, I'm not sure what's going on here. However, this looks like it's going to be this value here. Interesting. So, let me think about this a minute. So I'm just going to continue. I think it's just a coincidence that our information turns out to be the same. But this is going to give me 18x plus 198. And that equals 360. Just like over here, I subtract the 198 and we get 162. And when we divide, we get x equals 9. Okay, so this is very ironic that I have two examples where all the math looks the same. But anyway, we'll continue. So the measure of angle M is going to be measure of angle M equals, all I have to do is take 10, multiply it by 9, and subtract 5. So the measure of angle M is 85 degrees. All right, so that's just giving us a little practice with finding and knowing that the angle measures of a quadrilateral add up to be 360. All right, so let's talk about families of quadrilaterals. You've got concave quadrilaterals and you've got convex quadrilaterals. Now notice both of these have 4 sides and therefore they're quadrilaterals. But notice that this side, or this figure, actually looks like a side has been caved in. So that is one that we would consider to be concave. It is a concave quadrilateral. And then a convex is a nice, pretty, 4-sided figure. And the types of quadrilaterals that we'll focus on that have nice figure that's 4-sided will be trapezoids, parallelograms, and kites. So this lesson, we're just going to simply finish this lesson out by talking about the characteristics of each of these. And so I'm going to scoot this up a little bit. So what is a kite? Notice that this figure is 4 sides. And notice that none of the sides are parallel. There are no 2 sides that are parallel. Nothing indicates that any pair of sides are parallel. That's when you have a kite. And it kind of looks like a kite, but you have a kite when there are no parallel sides in a 4-sided figure. Okay, so now let's talk about trapezoids. So in a trapezoid, pull that down a little bit. With a trapezoid, you have 1 pair of parallel sides. And so notice in this figure, this little notation here, this little symbol indicates that these 2 sides are parallel, and even these 2 don't look parallel, but I know that they're not parallel because there's no symbol that indicates that they are. So a trapezoid will be a four-sided figure that has one pair of parallel sides. So that's what a trapezoid is. Now, a trapezoid can look different ways, can look a little different. As long as they have four sides and one pair that are parallel, then we have a trapezoid. So in this figure, this little symbol, which I've kind of colored over, these two sides are parallel, and we call this an isosceles trapezoid. This particular trapezoid we consider, and I like this one, to me is more obvious, but this is considered a right trapezoid because the parallel sides form a right angle with one of the additional sides. And so that would be a right trapezoid. And then finally, for this lesson, we're going to talk about a parallelogram. So a parallelogram is a four-sided figure where you have two pairs of parallel lines. So this side, these two sides are parallel. They are parallel to each other. And then you have this side, and this side is parallel, and I will just put a little marking there. So notice that we have two pairs of parallel sides, and therefore it is a parallelogram. Now, a parallelogram can look three different ways. They can look like a rectangle. Oops, sorry. It looks like a rectangle, which has two pair of congruent sides, meaning these two are congruent and these two are congruent. You have a square, where all sides are congruent to each other. And you have a rhombus that is a four-sided figure where you have two pair of parallel lines and the sides are all congruent, but the four angles are not the same, but opposite angles are congruent. So that's where you have, like these two angles are congruent and these two angles are congruent. But in a square, the four angles are 90 degrees. As is a rectangle, the four corners are right angles. So that's going to carry us to, that's going to get us started for Unit 5. And in the lessons that follow, we're going to focus on parallelograms, rhombuses, squares, and rectangles.